of high-speed digital flash pictures that I've taken of these films while they're oscillating. You saw the video camera, the real motion, and these are high-speed digital flash pictures that I've just made a quick video of for the downlink here, showing the different stages of droplet formation on the ends of these films while it's undergoing oscillation. And there you see one where it balled off one of these drops.
And Don,
and these films look a lot. These films look a lot like splashes when you see the classic milk drop going into a glass of milk, or raindrops splashing on a hard surface. They look a lot like those classic pictures, but the dynamics and physics involved in these films is completely different. And of course, they're governed highly by surface tension forces in the absence of gravitational forces here. And you can see these are just a whole bunch of flash pictures taken at various stages of the film oscillating with these droplets in the process of being spalled off. And I'm pausing it here just for a moment to explain something that I thought was really cool. When you look at droplets splashing in water in 1G, the surfaces will always be curved. But here you can see that little stem coming out. It looks like it almost has parallel sides, like it's got a constant diameter as it extends from the drop back down to the film. And I've never seen that kind of behavior before. Always when you have these extended drops coming out from a liquid surface under the influence of gravity, the surfaces are always curved, tapered.
And we copy all, Don. These are just fantastic pictures.
And I stuck a whole bunch of on here, probably more pictures than you guys want to look at. But I'll just keep running these.
Yeah, just keep running them. Every one of them is just.
From my point of view, you can never see too many pictures of droplets like this. And here you can see some waves occurring on that pedestal that was coming out from that one. And here you've got kind of an inverse because the drops can fall off from either side of the film as it oscillates. And if you happen to take a picture on the back side of the film, it looks more like a little depression rather than a jet of water coming out. And now here I found it interesting, as you oscillate these films back and forth, you spall off droplets of water, and the film gets thinner and thinner and thinner, and its mass becomes less and less and less, and as it's oscillating, it thins out like this, and it stretches into this conical shape, and you can start to see interference colors. So you're oscillating this thing back and forth, and all of a sudden now you can see interference colors where before you couldn't because of the thickness of the film. And some of these pictures start to show some of the interference colors. They're not as brilliant as what you see in a soap bubble, but you can start to see some of the interference colors develop. There you can start to see some interference colors. And here's an interference pattern forming in the center of the film. This was captured right before it broke. And there's the film when it broke. And here I lucked out. I caught a film right in the middle of breaking, and you can see running down the center of the wire frame is the edge of the film as it's breaking. To the left, you have the film. To the right, there's no film. And along that edge, you can see it's a whole series of little tiny spherical droplets forming as that edge is in the process of moving to the left and breaking up. And again, you can see these droplets coming out with sides that look almost parallel. They don't have the highly conical shaped surfaces that you see droplets momentarily forming from a splash under the influence of gravity. And all these digital still images have been put on the server and are available for downlink if they haven't already been brought down by OCA. And there's a film. The film is actually concave the other direction, leaving a drop sticking out in front.